Okay, so let us start. So in the last couple of days, we were discussing the second topic of our course, which is a review of Python. And so far, we have seen all the topics in bullet number 1. In the last class, we stopped in the string methods. And today, we are going to start a new topic, which is Numpy Library. Hopefully, we'll try to finish up to sorting. And if you have time, maybe further. And in the next class, we will finish this topic altogether. So before we proceed, let us quickly revise what we have seen in bullet number 1. Okay, so let us see when to use list comprehension. Okay, when to use list comprehension, and maybe the syntax, not exactly perfect syntax, but rough idea of syntax. So can anybody tell me when to use list comprehensions? Yeah, that's right. Whenever you want to create a list or to make a list in Python, think about list comprehension. And what could be a syntax for that? Well, within the square brackets, you have the elements of the list to be appended, and then you have the loop. Okay, yes, that's good. Yes. Okay. Now, what about the enumerate function? What about the enumerate? Where to use it? And sorry, when to use it? Okay. Yes. Not count list, but I think the best answer is whenever you want to iterate over list. Actually, remember in Python, it is not just list over which you iterate. You iterate over a list, zip list or dictionaries or strings, or so many objects of different types, and all of them are called as iterables. Okay, iterables. So whenever you iterate over iterables, for sure you will get the element. Okay, the element. But sometimes you're also interested in the index. If that is the case, then you use enumerate. Okay, so whenever you're using for loop to iterate, and you are interested in knowing the index, then you're going to use it. So by default, you get this for e in, let's say, some iterable. Okay, but when you are interested in the index, then you do enumerate, and you will get the index. Okay, so there is something in Arabic, something secret, or what?
He was asking about the voice.
About the?
Just I am asking, is there any sound or not?
Okay, you cannot hear me?
I leave it and again, back again.
Okay, okay, okay. All right. Okay. Now, what about zip? This function that we have seen in the last class, when to use it? Yeah, whenever you want to combine two lists, you use zip. Okay, but not all possible combination of elements. Okay, it is element-wise, pair-wise combination. Okay, it's element-wise, pair-wise combination. Okay, so if you want to combine lists, then you use it. And for example, the syntax is straightforward. You just say zip and list 1, list 2. So what it does, it takes the first element from here, and combine it in a tuple, and so on and so forth. And in the end, what you get is a list of tuples. That's right. Okay, that's right. All right. How about dictionaries? When do you use dictionaries? Yes. So sometimes the lists, the list can contain, any types of values, but the index will be for sure zero, starts from zero and goes on. Okay. And sometimes it is not that easy, not intuitive to remember. And let us say if you want to have some mechanism, then that mechanism is easily available by dictionaries. So if you want to store or have data and use it in the form of key value pairs, where key are unique, like index and list are unique, key are unique, then you must go with the dictionaries. How to create dictionary? Well, dictionary can be created in different styles. The one that we learned is a simple style, where we get the dictionary from the zip, excuse me, from the zip of to list. Yeah. So that is how you get the dictionary. This is one way. You can also use something like list comprehension, but with the flower brackets, key value pair with loop, and you can also get the dictionary. Yeah, and the first list, or okay, what is this? Okay, let me. I think this is. You can hear me? Can you hear me, guys? Okay, so there is this um, issue with the pen app I'm using, so I have to just restart the pen app. I hope it remembers all the things that we did. Yes, it remembers. Okay, all right. So sometime it crashes. Okay. Yeah. So we are done with the dictionaries, and the last thing is the string methods. Okay. The string methods, and we have seen so many string methods. Yeah, yeah, you can do that. Yes. Okay. So there are so many string methods that we have seen. Do you remember some of the methods, string methods that we have seen? Yeah, we have seen join. We have seen, okay. Yeah, we can get so many string methods, but yes, split, strip, capitalize. So some of the methods that we are going to use heavily in this course are here. Split. You split the string based on certain criteria. Yeah, the other one that we use a lot is replace, and the other one that we use a lot is join. Apart from this, yes, we have seen some other methods. For example, we have seen strip, we have seen capitalize. Okay, and there are many more methods of string. Okay, but in our course in data, whenever you get data which have strings, then yes, split, replace, join are the usual ones that we use. Okay. Yeah, and this is all what we have seen in the last class. Do you have any questions, any comments? Do you have any questions, any comments? Okay, then let us start with the new topic. So today we are going to start a new topic, which is Numpy Library. See, in Python, and also maybe in other languages, but Python and R programming are very popular in this, that there is a lot of community. There are a lot of actually programmers who write some codes and create libraries. The good thing about library is that they are available for free and you can use them in your codes. So what it means is you don't have to write your code from the scratch all the time. There are some nice libraries available for you. You can use that, and then you can code based on those libraries. So a lot of groundwork is actually done. This is something very nice. Now, for all those programming tasks that requires scientific computations, numerical computations, requires doing playing with numbers or equations or differential equations, algebra, and things of that sort. Okay, you have two popular libraries, NumPy and SciPy. Okay, and one of them is here, NumPy, that we are going to discuss now. And this library is a very useful library, and you will see later on that all the data science libraries and plotting libraries are built on NumPy. So it is one of the must library that you should know if you want to do something with data science. Okay, and this again, it's a free library, and if you are using Anaconda, and I believe all of us here are using Anaconda package, Anaconda repository, and the Jupyter notebook from Anaconda, uh, then NumPy is like a standard library installed for you by default. So all you need to do is to call import NumPy, and this is how you do import NumPy. You must did like import math or from math, from math import maybe random or something, right? So it's the same style. You just import NumPy. Um, the Python, when you import a library, gives you something much more to control the name. Sometimes NumPy maybe you feel that it's too big and you want to have something very short. Then you can add this extra clause. You can say as NP. So everything in NumPy is renamed for your reference as NumPy. So if you want to say NumPy dot something, you just say NP dot something. And for NumPy, this NP is almost like you can say alias. It's an acronym, and you can have here any acronym that you like. It's anything that you like, and it will be there. Okay, but this NP is like an acronym. No, it's like a reference. Okay, instead of calling NumPy, you call NP. So it's like alias, another name. That's name for your program now. So after this line or anywhere in the program, instead of NumPy, you call it as NP. So it's like using a shortcut and name for this name. And this NP for NumPy is almost like a standard. Okay, if you find any code online, NP, it by default means NumPy. So it is almost like a standard. Okay. Now, sometimes the NumPy might not be installed. With Anaconda, yes, it is part of the Anaconda package. It is there in Anaconda. But if you're using PyCharm or any other repository of Python, then you have to install everything from scratch. If that is the case, then you can install like this. You just have pip install NumPy, something like this. And if you want to install through Jupyter Notebooks, you just write the exclamation mark, the pipeline of pipe operator, okay, and then you write pip install NumPy, and it will install. And you can install any other package of your choice. Yes, Faisal?
You can write this command in the CMD command prompt or in Jupyter.
Yeah, this one in Jupyter, yes, if you want to write it in command prompt, it's fine, but this is easy. You write it here in Jupyter Notebooks.
Oh, okay.
Okay.
Because I've installed Jupyter Notebook, but not in the Anaconda way, because I've changed my computer, so from the ICS classes.
Okay. Yeah, you can also use a PowerShell, and if you didn't install Jupyter Notebooks through Anaconda, then check if you have NumPy. If not, you just create a new cell and execute this, and you can install from here. You can install from here. This is the easy one, but like Hadi and others suggested, you can go to the Anaconda PowerShell or Anaconda shell, and then you can install it from there as well. For example, let me show you. You don't have to go to the PowerShell. You can go to the prompt shell and you can install from here as well. So yeah, but I think this is the easy one. You don't have to go anywhere. Just install here and run here, and it should be fine. Okay. Now let us see some basics about NumPy library, and we will start with creating NumPy arrays. Now for the wordings, please let me make it clear. Whenever we say list, it means the Python list, the usual list of Python. But whenever we say array, it means the NumPy array. It's an array and list are the same, to be frank. And if you are seeing C programming, NumPy list or array are usually the same. Okay, yeah, like no. This one, arrays are immutable. This statement is not right for Python. Okay. Okay, Hadi. Okay. So in Python, at least in our class, we are going to differentiate arrays from list. Maybe in ICS 104 it wasn't there, because in ICS 104 NumPy wasn't there to begin with. So maybe list and arrays were called by the same name, right? Yes, no, or there was no mention of array in ICS 104. Not NumPy. I'm not talking about NumPy. I'm talking about the word array. Have you heard about this word array in 104? Okay, so that's good then. So for somebody who's not in Python, for him list or array are the same. And if you ask somebody from any other, even from mathematics, they say array or list are the same. But in Python, at least in our course, we differentiate these two words. List for us means the list from Python. Okay. But when you say array or ND array, n-dimensional array, or in short array, that means it's an array from NumPy. Okay, array from NumPy. Now look-wise, they might look the same with minor differences, but properties-wise, they are very different. Property-wise, they are very different. And with some examples, we'll see the differences. Okay. So let us create a list, and let us see how to create an integer array. Let me scroll. So the first task is to create an integer array of 10 elements with all zeros. So how to create that? Well, you can create a list. Sometimes you can do it also like this shortcut. And so you can do that, and you can say the list. Okay. To create NumPy array, there are two options. Either you create from scratch or use the existing list. For example, I'm going to do the same. I'm going to say use this list one. So this array one is now an array in NumPy that is created from list one. And you can check the type and the list, and this is how it looks. Okay. So you see, look-wise, yes, maybe the commas are missing. That's a minor difference. But the main difference is the class itself has changed. Instead of a list, it is now the array or NumPy array. Okay. This is one way, but that's not the only way. And we are going to learn some better ways to create the arrays. The one that we're interested to learn is this. Since this is an array of all zeros, NumPy has some inbuilt methods. For example, NumPy zeros given the size, which is, let's say here how much, 10, and you can give, for example, data type, but we'll see in a minute. We'll create an array, and we can print all of this. And you get NumPy array with all zeros. By default, the other difference between list and array is list could have different data types. Okay, list could have different data types. For example, the element 1 could be string, element 2 could be integer, element 3 could be float. The array on the other side will have the same data type. All the elements should have the same data type. That is one must. That's a requirement. Okay. By default, NumPy will create a float array. If you want to make it as integer, you have to specify that it must be integer. Or it will look at the context. From the context, it gets the right data type. So here it was all integers, so from the context it got okay. But here, because we're creating from scratch, we have to mention that. For zip, you have to have lists. Okay, for zip you have to have lists. Okay, for example, if I say, it might work, I'm not sure, because things are changing in Python every now and then, but the best I remember is that it must be a list. Yeah, it is working. Okay, we can use arrays and it works. Yeah, but what I used to remember was only list will work. So this is update for me as well, that arrays can also be used in the zip. Okay, all right. So here is another advantage of NumPy, that you have lots of inbuilt methods to create arrays. And here is the first that we have seen, to create an array of 10 elements with all zeros as integers. Okay, with all zeros as integers. And you have so many ways to create the list. You can.
What's the difference between MB array and MB dot zeros?
We'll see as we proceed. We'll see as we proceed what's the difference between. Oh, you mean difference between these two? It's the
Yes.
same. No, you in the end what you get is the same. Array 1, array 2 are the same. Okay, you use NumPy array to convert existing list to array. To convert a list to array, we use numpy.array, np array. Whereas numpy or npy.0, this is to create array from scratch. Okay, we are not using the help of list. Here we need a list to create the array. That's the only difference. But once the arrays are created, array 1, array 2, they have no difference. They are the same. Why do we make array of zeros? It was asked in the question. It was asked here. Create an integer array of 10 elements filled with all zeros. Okay, is that clear? All right. Now let's look at the next question. It says create a 3 by 5. Okay. What if we didn't specify the data type? So by default, this is always the case. There are certain things that are optional. Data type is optional. By default, it will take it from the context. If nothing is there for NumPy, for numbers, the default one is float. So if you don't specify the data type like we did before, it will create the floating array. Every decimal, every element will be a float. Okay. Yeah. All right. Now let's look at the next question. It says create a 3 by 5 floating point array filled with ones. So now you want array filled with all ones. Okay. Array filled with all ones. So that is easy. You just say ones, and then it's the array. And here you need to mention the size. So to mention the size, usually you write it like this. And now you get 3 by 5 array, 3 rows, 5 columns with all ones. So that's a nice thing about NumPy. It gives you so many methods that you don't have to build everything from scratch. If it was just Python, you have to use list comprehensions, and maybe you have to use nested loops to do this. But here it's just a single line of code and everything is done. 1 point. This is just float. Let me just change the data type. That 1 point is telling us that the data type is float. Now data type is integer. You know this, right? In Python? Yeah. If we had different values, how would we do that? What do you mean different values? I didn't get that, Hadi. Different same values or different values everywhere? So all the numbers are 2. That's what you mean, Kumail? Yes, so we'll see that we are actually creating that, okay, in the next example. So the third example is asking us to create a 3 by 5 array filled with pi values. And to do that, we just say numpy dot full, okay, and here numpy dot full take 2 arguments. Actually, for each function, let me first create this, and for example here I can write 2, and you see that all of them are 2. Is this what you guys were saying? Right? This is what you were asking, Hadi and Kumail. Can you hear me? Okay, yeah. Now, see, there are so many methods. But here I never use pi. I will use pi in a minute. I'm just using 2. Okay. I will use pi in a minute. But whenever you want to know more about any method, always go to the help and oh, I typed it wrong. So always go with the help and see. Okay. So here you see it gives you, these are all the arguments that you can have for this function. There are 2 types of arguments in a Python function: the positional arguments and keyword arguments. You see there's a difference. Here it's just shape. How do I know the value entered is shape? It's just because of position. The first value that will be entered will be the shape. The second value that will be entered will be the value to fill. Now these values, these extra arguments, they are different. They have equal to, on the left hand side is the keyword, and the right hand side is the default value. This is the keyword. Order is the keyword, and the right hand side value is the default value. Now if you don't mention anything, the default data type and default order will be selected. Otherwise you can have not the default. The default, if it is none, it is by context. Otherwise you will have some default data type. Okay, so these are keyword arguments, or these are like optional arguments. If you don't mention, the program or the software will, the method will assign some default values based on the context or based on the fill value. Okay. So what is order here? Order is another keyword argument. It's optional, so you don't have to give it. It is just how you store the array. Do you like to store the array in the C programming style or in the Fortran programming style? That's how that's what it's asking. See, all the methods in NumPy are very efficient. And once you write things here, it will execute something behind the screen, and those executions are very optimized. And to have very efficient code, Python is not the best language. To have very fast code, Fortran is the fastest language. So that's what NumPy is doing. Behind the, once you give the codes, it will execute the NumPy code and gives you the answer. Okay. How can we use yeah. So the order here just tells you about should we use the C style or the Fortran style in storing, and usually you don't worry about this order in creating. Okay, the important ones are here, the mandatory options. All right, Osama, the shape is 3 by 5. Yes, 3 by 5, 3 rows, 5 columns. Okay, 3 by 5 means 3 rows, 5 columns. Okay, so that's the question we are looking at. Create an array filled with pi values 3 by 5. So we didn't yet use pi, but at least we have the array of 3 by 5. Okay, 3 rows, 5 columns. Okay, Muhammad, how can we use the element inside the array? We will see that how to capture, for example, how to pick this 2 and modify it, or use it for any other purpose. We will see in the next section. We have indexing. We will see how to use that. Okay, Muhammad, just wait for that. All right. So now here instead of 2, we want us to fill with pi value. Do you know what is the pi value? What is the pi value?
3.13.
Yeah. So you can use that, or NumPy has also a huge number of constants stored for you. Anything which has to do with mathematics, physics, it's that scientific computing. So you have all the pi values here with a very precise, decimal point accuracy. If you want to, reduce the accuracy, or you want to round things, you can round the pi value here, or you can round the entire array. It's your choice. Okay. In the slides, I think I'm showing you how to round this and np.pi. But if you want to round everything, you can say np.round, okay, and set the number of decimals, for example, 2, and that will be the case. Okay. So you can use the round function from numpy, and also round the entire array, n-dimensional array. Okay, so that answers question number 3. All right. Now let's look at question number 4. It says create a 3 by 3 array of uniformly distributed random values between 0 and 1. So random values are very important if you're building any algorithm or any procedure. You need to think about some randomness, and especially in the heuristics, you need to have some random. So random values plays very important role in many applications. Usually, from your math classes, from 104, you must have math library for random. But for NumPy, things are much simple and straightforward. You have in NumPy random method to create random numbers between 0 and 1. Okay, this is one option, or there is another option that is also very popular. Actually, I prefer the other one. This style is similar to your math, but then there's also another one which is similar to MATLAB and something that I used to use. So this is the two ways. Okay, numpy random.rand with number of rows and columns, or numpy random.random where you have the rows and columns as one in one single as a tuple. Okay, so these are the two ways. Now whenever I execute this, you see the numbers are changing, and this is meant to be because they are random numbers, right? Because they are random numbers, they are meant to be changed. But most of the time I want to have a consistency in the numbers, so that when I repeat my experiments, it should be the same. Okay, when I repeat the experiment, yes, seed, yeah, that's right, Hadi. So when I repeat the experiment, I should get the same effect. Or for example, if I give the code to somebody else, when he executes it, he should find similar results. So we need to have this reproducibility. To do that, we set the seed, and the seed setting is also very easy in NumPy. We just say numpy.random.seed and give a number. For example, I'll say 89. Now, how many times as I execute, I will get the same matrix. So if I have, let's say, 2 matrices, they will have the same numbers, not changing. If I want the second one to repeat like the first, just copy the seed here. So you're initializing the seed here, and then these two arrays will be exactly the same. See here, exactly the same, and you can do the comparison. Okay, so you usually, whenever you're using randomness, you try to remember the seed so that we can reproduce or get the same results. Okay. So to create a 3 by 5 array of uniformly distributed numbers, you have these two options. Okay. Now you have next question to create a 3 by 5 array of yeah. So Faisal gave the answer, but yes, create a 3 by 5 array of random integers in the interval 0 to 10. So whenever you say random integers, you need to know what should be the lowest and what should be the highest value. And for that, we had this command rand int, Rand int again takes a different set of arguments. 0 is the minimum integer value that should be selected, and if I write here 10, it means the maximum value will be 9. So this 10 is not inclusive. How do I know that? Well, once again, you don't have to memorize things. Of course, knowing what function to use is important. But other than that, you can go here, and here you can read more about the rand int. Rand int shows here that the low value is inclusive. You see the brackets here. It is an inclusive value. For the high value, it is exclusive. It says here, random integers from low inclusive, high exclusive. This style, low inclusive, high exclusive, it's common in Python. So that's why it is being also used in NumPy. Okay, and that's the syntax. You have one positional argument, which is low. For the high value, by default, it's none, but you could give any high if you are interested in. Then the size option. The size option, if it is only just size like this, then that means you have to give a tuple of size. And then the data type, all these are optional, or keyword arguments. The good thing about keyword argument is you can play with them. Play in the sense you can have your own order. And let me just show what I mean by that. So if I write it like this, it means that's a high value. But otherwise, I could specify. Sorry. Otherwise, I could specify. Similarly, the size. Okay, I don't want just one number, right? I don't want just one number. How many numbers I want? I want 3 by 3 matrix. Okay, so I could say here size 3 by 3. Because these are keyword arguments, the order doesn't matter. It will matter if you are removing the key. If you're not removing the key, you can put it in any order of your choice and you'll get the same. But let's say you want to remove the key here, then this is wrong. So if you want to remove the key, at least you follow the order, okay, like that. Okay. So there are certain keyword arguments, and if you're using the key for the keyword arguments, it should be it could be anywhere. But if you're not using the key, then it doesn't matter, but it should follow the sequence. So if you follow the sequence, the code will remember that this is for high, this is for the shape, and if you want to give data type, you could just write here int, okay, or let's say, well, there is no other option, is rand int, so it should be integer. So that is how you get a 3 by 3 random integers, okay. And finally, the identity matrix. To get the identity matrix, identity is not a random thing, so it's just matrix, and you have this EYE for identity matrix, and you give the size. For example, you can say 4 by 4, and then you get a 4 by 4 identity matrix. You can give the data type as int, and you get all integers. You see all are ones and zeros. So here the question is 3 by 3, so just write here 3. And remember, identity matrix is always square, so the other dimension is not needed. So that's it. That is how you get the identity matrix of size 3 by 3. Any questions? Any comments? All these codes are here, I know, in the following, somewhere also we are writing the explanation, but the video is also available. Any questions? Any comments? All right. So now we move to the attributes of NumPy array. NumPy array, I think somebody asked what is the difference between list and array. They look the same. So NumPy array has lots of attributes, and you can do many more things with NumPy array. As we proceed, we will see, and the crux is here, the vectorized operations, the broadcasting, and these things makes your program very, very fast. Okay, but we'll start with some basics, and here are the basics. For a NumPy, okay, let's create a random NumPy array. it's a random, it's a 5 rows, and it's 5 elements maybe. Let's call it array 1. Now for any NumPy array, you will have some default things. For example, that's your NumPy array. How many elements you have in here? 5 elements, right? What dimension array it is? 1 dimension or 2 dimension? 1 dimension. So for every NumPy array, there are the basic attributes that you will be finding. For example, I would say dimension, and not it should be n dimension, sorry. And it will give me that it's 1-dimensional array. If I type here, let us say the shape, then it will tell me how many rows and columns I have. It just when it writes 5 comma empty, it is saying that it's 1-dimensional and it has 5 elements. You can take it as a row containing 5 columns. So it's a row vector containing 5 columns. Yeah, 5 by 1. But that one is not defined. Okay, so it's you cannot say 5 by 1. Either you just take it as an 1D array of 5 elements, or you can take it as 1 row 5 columns, which I don't which is not the best, but at least we do it. But to be safe, you always imagine this as 1-dimensional array with 5 elements. That's it. By saying it 5 by 1, we are saying that there are 5 rows and 1 column, which is not the case here. Okay, which is not the case. I know that in mathematics, yes, 5 by 1, it looks like this maybe, but no, in programming, it will not be the case. And then to know the total number of elements, you could also have the size. So in this case, it is not that different. You will not see the difference. But let us have another dimension, and then you will see. So let's say I have 5 by 4. So if I have a 5 by 4 matrix, let me print it first for you. What can you say about the dimensions of this 5 by 4 matrix? How many dimensions you have here? No dimensions. Dimensions will be 2. Yes, 2 dimensions. Okay. If you have 1D vector like before, it was 1 dimension, but here it is 2 dimensions. 2, in a sense, you have dimensions for the rows and dimensions for the columns. Okay. So it has 2 dimensions. How about the shape? What is the shape of this matrix? Yes, the shape is 5 rows and 4 columns. How about the size? Size means the total number of elements, which is 20. Yes, that's right. Okay. So that is how you get different properties from the array. These are the basic attributes. I will see more. There are more things that is involved, but these are something basic. You cannot get the same thing for the list. If you say list.endim, you will not get anything because that's the Python's list. It doesn't have that attribute.
Doctor, I am sorry, but NDIM, what's the meaning? For what?
It's the dimensions. It's a scalar. You have scalar vector matrices, right? Have you heard about this scalar vector matrices?
Yes, to scale up.
So, no. So, let me print 3 things for you. So I'm printing 3 arrays. Okay. This is just a number, right? Array 0 is just one number, isn't it? So this is scalar. How many dimensions it has? It has 0 dimensions. Okay. The next one, array 2, that I printed, has 3 numbers. Okay. It could be row or column, or you can just say it's one-dimensional array. It's one-dimensional array, like vectors. You must have heard about vectors in physics and math.
Yes.
Okay. Now this is another array which has 5 rows and 4 columns. So it has 2 dimensions. So ndim for this will be 0. Okay. So if I write here ndim, for this it will be 0. For this it will be 1, and for this it will be 2. Okay, it says float object has, yeah, because it's a 0 thing, so it says there is nothing.
Yeah.
Okay, that's one.
Okay.
But for the others
Is
it will be 1 and 2.
there 3 in them?
Yes, you can have 3 also. Usually we don't go in tensors, yeah, but we will have 3 also. So let's say 5 by 4 by 2. It will actually look a bit, like this. So that's the so you will have 5 matrices, each of 4 by 2. That's the way we can depict, because it's a 3-dimensional thing. To depict in 2 dimensions, you have to slice it. Okay, and these are called as tensors. So you have scalars, vector, matrices, tensors. It goes on. But for our course, we only need up to 2-dimensional. We don't go in 3 and beyond. Okay, but yes, you can have 3 dimensions. You can have 4 dimensions, and things can go on and on. Okay, and you can type here, instead of this, you can type here ndim, and it will tell you it's a 4-dimensional thing. All right, any other questions? Okay. So now we move to the next and very important concept, which is indexing. So for a list, in your Python list, you know how to access the elements. If you have a list, to access the elements, use the square brackets. Okay. Here also we're going to use the square brackets to access the elements. Now for one-dimensional arrays, it's exactly the same as one-dimensional lists. You just have the usual thing, and here you can write the start index. Okay, here it is the end index, but it is not inclusive. Okay, so it's exclusive. And finally, what do you have here? The step. Yeah, the steps. By default it is 1, and this is the optional thing. If you don't write this, it is by default 1. Otherwise you can have your own step. The same thing for one-dimensional ND array. Okay, and by default the start will be 0. By default this will be 0, and by default this will be 1, and by default, if you don't write anything, by default it will be end. Whatever is the thing for end. Okay, there's no number actually. Okay. Now the difference comes in 2-dimensional arrays, and for that let me give you an example. Let me create a 2-dimensional list. Okay. Say 1, 2, 3, 4, 5, 6, 7, 8, 9. That is the 2-dimensional list. Let us say I want to cache this element from the list. How to do that? How to cache this element? Yes. So you need 2 square brackets. The first square bracket will say which sub list to go. So it's a 0, 1, 2. Okay, 2. And then in this sublist, which one? So it is the first one, which is 0. So if you do that, you get the 7. Okay. Yes, you get the 7. Now in the NumPy array, things are different. So to create that, to show the difference, let me copy it from there. How to convert this list to array? Just say NumPy array list1, and you can print it. And look-wise, it looks the same, really not a difference. Okay, but to extract the elements, you have a different style altogether. Okay. Here, you do it like this. So in one square bracket, you separate by comma the dimensions. So here you are saying 2 for the third list, and then in the third list it was 0. So it was like a nested list. Here it is not a nested list, and that gives much flexibility and power. And maybe when we come to slicing, I will highlight this difference again. Then I can show. I don't know. Even now I can show. For example, if you want to extract this, it's very easy. You just say list 0, and you will get these numbers. But what will be difficult is to get the first one from here, the first one from here, the first one from here. This will be slightly not straightforward to get from such lists. Okay. If I write it like this, it will be an error. If I say get all elements, still I will get 1, 2, 3 only. Whereas in the array, because it's no more like list inside the list, it is no more nested, it will be easy. For example, I will say give me all the rows, the first column, and I will get 1, 4, 7. So you see that the difference is huge. Here you have a nested list, so list inside the list. But here, no, it is an array where you have rows and columns, and you can pick row-wise or column-wise, or you could pick, your own subset. So that is one of the difference in indexing, and this difference is very strong. And we'll see more about this when we come to the slicing, the next chapter. Okay, next topic.
Always gives us the element in the row.
Can you repeat?
In the row, not in the column. Like 1, 4, 7 should be a column.
Yeah,
The result.
yeah. So this is something that the NumPy will not maintain. If you have a 1D, one-dimensional, it will just throw it as a row. Yes, it will throw it as a row. Yeah, it should be column. Yes, that's right. But whenever 1D, that's why I said when you have one-dimensional thing, it writes like 5 comma empty. So if you want to make it a row or column, you have to do something. Okay, but by default, it will throw it like a row. It will not, make it it will not make a column vector. You have to make a column vector, and we'll see when we go to reshape. We'll see how we can make a column vector out of it. Okay, but by default, if you have one dimensions, the NumPy will give a row vector, which is a drawback. But no, that is something I don't know why they keep it so even now. They didn't fix it, but maybe this is maybe easy for them in coding. That's a key difference for two-dimensional arrays. Instead of 2 square brackets, you have a single square bracket separated by comma. So if you have another question. So if you want to create an array with an elements that I want, this is one way, but you can create from scratch in Numpy. You can create your own array. You can create a list and convert it to array. This is one way. The other way is you create in NumPy manually the array. All right. Now let us see more about indexing. Sorry, let's copy this. So I'm creating a random array of 5 elements, and those are the indices. Okay, so if you start from here, it is 0, 1, 2, 3, 4, 5, but otherwise, you know, it is -1, -2, -3, right? You know all this, the same thing that we have from Python, -1. So one-dimensional arrays are really the same like list in terms of indexing. From 2 dimensions, it becomes challenging. Okay, it shows the difference, so on and so forth. Okay, so now what will this give me? X 1, 0. What will I get if I print this? It will give me 5 because that's the index 0 element. Okay, how about this x14? Well, x14 will give me 7. Yes, now we are getting the right answers. It will give 7 because that's the 4th index. Okay. Okay. How about this x -1?
9.
Yeah, this will be 9. So -1 corresponds to the last element. Okay. So that will be 9 because it's the last element. How about -2? Yeah, 7. Okay. So let us execute it and verify that
Yes,
we're on the
I
right
don't
track.
understand the last point.
Which was
How can you
-2,
get this
you mean?
number? No, all this number 0, 4, -1, -2. How can I get the answer?
Okay. So you didn't understand this, you mean?
Yes.
Okay, so let me just go back here. Okay, so here x1 of 0. What it means? It means just give me the 0th index, the value at the 0 index. And you see here, this is the array, right? 500379. At the 0 index, the value is 5. So when I say x1 of 0, you will get the value 5. Okay. Similarly, when I say x1 of 4, it will look at the value at index 4. So what is the value of index 4?
Yes, yes. I think I get it. I get it.
You got it, right? Okay.
Yes, yes.
So just to make sure that our answers are right, execute it and see. Yes, so you get the same answers that we discussed, 57997. Okay. So that's the easy one. Now let us look at the 2 dimensions. Okay. So I'll copy this code from here. By the way, these notebook extensions that I'm using, please, if you want to know what extensions these are, let me know, or you can also Google. Having these extensions is very handy. For example, I use this Scratchpad a lot. The other one is just highlighting this. I was also using before Hinterland, but then I realized it is consuming, it is creating lots of typos. But there is a very good one called Hinterland. You can use that, and there are many extensions of NumPy notebooks, like coming up with the page numbers, and sometimes to hide the code, many things. Okay, you have so many extensions. Hinterland is bad because when I was typing, it was giving it's like autocorrect. So sometimes you don't want it, and he was correcting you. But sometimes you don't know, and then he is guiding you in the right direction. Okay. All right. So now let us look at this indexing for 2-dimensional array, and this is a 2-dimensional array. Okay, and it has the same index. For example, you can say this is index 0, row wise 1, 2. Similarly, column wise, this is index 0, 1, 2, 3. Or you can say this is -1, -2, -3. And here you can say -1. So let me not write it there. It's going to overlap. So it's -1, -2, -3, and this is -4. So you have this, and you can use mix and match, and and remember you had this style. So you start and step, and you could have many combinations and slices. Okay, so let us see what we have here. It says x21. What is x21? It's the number 4 from here. Yes, that's right. How about x20? How about x20? It's this one. How about 2 minus 4? How about 2 minus 4? So it's the same, right? Yes, it is the same. Yeah. Okay. Then how about minus 2 minus 3? How about minus 2 minus 3? That's right. So I think we all are now in the same page. Yeah. So that is how you can index in a NumPy array. And that's a huge difference. And I would say it's a huge improvement in the sense that, in Python, the n-dimensional list is nested list inside the list. But here it is not list inside the list. So you can go row wise or column wise and you will get the same thing. Okay. Okay. Any questions, any comments? Okay. So now we will move to the next topic, which is about slicing. Okay. By the way, you can update the values if you want, and this is I think something they are. Somebody said they are immutable, but no, they are mutable. The arrays are the list; they are mutable. You can change things and add extra elements if you want. And here is one example. Here in the same array that I have here, 503379. I'm just changing it to changing the first element to 3 point something. The only difference is in list you could have mix of data types, but in arrays no, you should have the same data type. So even though you are giving a float number, it is converting it to integer because your original array is integer. Okay, so it's converting it to integer. There is another point that I forgot to tell you, and maybe now I will just highlight this. Okay. Now, by default, if you print a NumPy array, this is how it prints. Sometimes you want to print it in the style of Python with commas. If you want to do that, you convert it, just for printing. This is only for printing. The array is not converted. It is not a Python list. Only to print, you do it. And if I check the type of x1, it is still NumPy array. You didn't convert it. It's just for printing. You convert it to you changed it to Python list. Why? Because it will add commas and it might be easy to read sometimes. Okay. Yeah, then it will change. What you said is right. Or better to do it like this. If you want to change, you can change like this. We can do it like this. Or I'm not sure because I only use the to list for printing, but I believe you can also do something like this. Yeah, it will also work. Okay. No, we're not changing the reference here. If I write it here without this line, it was just just for printing purposes. Okay, like this. It is just for printing purposes because it's not a permanent change. If you want to make a permanent change, you have to reassign x1 to the list either by this, which is not the common one. The common one is this. Okay, so now everything x1 is changed to actual list. Okay. All right. So you can update the values. For example, here I updated the first value, and here I'm updating the rows, first row, first column value. So instead of 5, it becomes now 12. Okay. Now we come to another important concept called slicing. Array slicing is like you're trying to get some small chunks, some subsets of the array by coming up with the right, cut to the array. So for that purpose, we have this array. Let us take this array. Now for this array, for this array, let us, we are done with the task 1. This is exactly, it says to create a random array of size 10. Okay. Now it says display first 5 elements. So how to display the first 5 elements of this? Anybody? So if I write it like this, it gives me all. All I want is the first 5 elements. Yes. So now we know the slicing. And remember the rule, by default, if you keep it empty, and then it will start from beginning. But if I want the first 5 elements, I should stop at index 4. So if I want to stop at index 4, I should write here 5, because 5 is not inclusive. Okay, so that is how you get it. How about this? Display elements from display elements from index 5 to the end. So starting from index 5 up to the end. Yeah, the opposite of that. Okay, 5 to end. So start from here up to the end. Okay. How about this? Elements from 4 to 6. That's right. So that is the challenge, not challenge, the difficult one. So 4 is inclusive. So if I want to have index 4, I've charted. But 6, if I want to have 6, the end is not inclusive. So I should have 1 extra there. Okay, 4 to 7. So this is something important. Please remember that. Okay. And now you get these numbers 4 to 6, which is 7, 9, 3. How about this? Display alternate elements from the first element. So I want to discuss 5, 3, 7, 3, 2. How to do that? Well, we know that we have to have the same start from the first element and at the last element. So this is not important. The important point is here, steps. So the steps should be 2. So if I write it like this, by default, it starts from the beginning. It should end at the last element. And the steps now should be 2. So after 5, it should go to 3. So after 5, it goes to 3, then 7, and so on and so forth. The next question is the same. Display alternate elements, but starting from the second element, not from the first element. So any ideas how to change it? Well, yes, because it says second element, and you see second element should have index 1. And this position is inclusive, right? This is inclusive. So I write here 1, and you get it. So 0, 3, 9, 5, 4. Okay. And what's this now? It says display element starting from the 4th element from the end. 4th element from the end and ending at the last but 1 element. So yes, we can do it 4th element from the end by counting this, but essentially he's asking us to use the negative indices. So can you tell me how to do that? 4th element from the end. Yes, so if you want to have 4th element from the end, so it is the first element, second, third, 4th element. So this one is exactly minus 4. Minus 1, minus 2, minus 3, minus 4. And where he wants you to stop? Just here. Okay, last but 1. So if I write here minus 1 corresponds to, by the way, end, right? But when you write it here, it is just before end, because the second place is exclusive. So just before the end, it will stop. And yes, you get this 3, 5, 2. So 4th element from the end to last but 1 element. If I want to get up to the end all the way, just write it like this. Okay, and the last question says display all elements in the reverse order. So if you want to go in the reverse order, it's the step that should be changed. Okay, yes, it's the step that should be changed. So minus 1 shows tell us to go in the reverse, in the opposite order. So you start from here, 4, 2, 5, 3, so 4, 2, 5, 3, so on. Okay. Similarly, if you want to go from any other direction in the reverse order, you have minus at the step. Okay, minus at the step. For example, here I say -4, which is this element, to let's say 1, 2, sorry, to here. So I will say 3. So I expect to get this, right? So it says 3, 9, 7. Yeah, because this is not inclusive. Sorry. So if I want to get up to here, it should have been 2. Okay. So this part is not inclusive. So whenever you want to go reverse, the minus is must. Okay. So that is how the slicing is done for one-dimensional array. Let's look at the. By the way, all the codes are here, and video is there. If anything is not clear, you immediately, you message and clarify. Okay. Now we have a 2D array here, and let us print first. Okay. All right. Okay. So that's the first part. Now how about this? Display first 2 rows and first 3 columns. So now you would like to display first 2 rows, so these 2 rows, but not all the columns, first 3 columns. So 503, 793, this small matrix, 503, 793. How to do that? Now remember, in arrays, you don't have to have 2 square brackets. It's just 1 square bracket. Okay, and then everything that you have in the list, like those 2 colons and start and is exactly here. And then after comma, you have those 2 colons and start and increment for the columns. So first for the rows and then for the columns. Okay, first for the rows and then for the columns. So let us see how many rows you want. You want the first 2, right? So how do you get first 2 in slice? Yes, what I think I got the right answers. So that is the first 2. So remember, the end is never inclusive. So 0 and 1, that's what you want, 0, 1. So you say start from 0, but stop just before 2. Okay. What about columns? Columns, it says start from 0, but stop just before 4. Stop just before. Sorry, just stop up to 3 columns. So index wise, it should be just before 3. Okay. So now you get it, 503, 793. Okay. So that's right. We have the right answers. Okay. How about this? Display all rows and every other column. And maybe it will stop here. Okay. So display all rows and every other column. If I want to display all of them, you just write this colon. So it start from the beginning and end at the end. Okay. So you just keep it empty, everything. So you want all rows. How about every other column? What is the meaning of every other column? It means the step should be 2. Okay. And now you see 5 and then 3, 3, 7, 5, 7, 2, 3, 3, 7. So that is how it's done. Okay. We'll continue from here in the next class. Okay. If you have any questions, any comments, please let me know now. Otherwise,